Number 5, we're going to multiply rational expressions. So when you multiply rational expressions, you need to factor everything completely. So I'm going to look at the first rational expression, x plus 3 over 4x. Nothing can factor here, so that is as factored as it can be. So I'm going to have x plus 3 over 4x. The second rational expression, or the second fraction, 2x squared plus 2x over x squared minus 2x minus 15, both the numerator and the denominator can factor. So I'm going to factor the numerator first. There is a GCF of a 2x. So I'm going to take out a 2x, and I'm left with x plus 1. The denominator is a trinomial, and I can factor the trinomial by reading backwards. What are the factors of 15 that subtract to get me 2? The answer is 3 and 5. I need a negative 2, so in order to have a negative 2 with 5 and 3, my negative needs to be on my 5 and a positive 3. Once everything is factored, the way that I multiply fractions is that I multiply the numerators and I multiply the denominators. I multiply straight across. So I'm going to multiply x plus 3 times 2x, x plus 1. I don't actually want to multiply these out because then I wouldn't have needed to factor. So I'm going to just write it, 2x plus 1 times x plus 3 over 4x, x plus 3, x minus 1. Once they are, or x minus 5, once they are one big rational expression, then I can look to simplify things. What is being on the numerator and then also on the denominator, because that means it is dividing by itself. So the x plus 3 is on the numerator and the denominator, so we can cross those out. The 2 and the 4 can simplify to make it 1 over 2. And then these x's can also eliminate because they are coefficients, or they're not coefficients, but they are monomials out in front. There's nothing being added or subtracted to them. So after this is all that can eliminate. All that I'm left with is an x plus 1 on the numerator, and then a 2 and an x minus 5 on the denominator. So then all of this would be my answer. I would not need excluded values here.